All right, welcome back. Okay, so welcome back again. And I think we have the next 45 minutes in which we will cover this domain two, which is actually very interesting domain and very important from the weightage standpoint, as I said earlier. And as you go through it, you'll realize that a lot of this concepts that are discussed here are pretty standard stuff that will apply across, cloud or non-cloud setups. Um, the only nuances of moving to cloud is that the data storage is not necessarily in your control, or rather, for that matter, the shared resources at large are not in your direct control as much as in the um, traditional model. And the same risks that we talked about, which is multi-tenancy, hypervisor, shared pool of resources, broad network access, are still the main avenues of risk to data security, which you would want to alleviate by putting in the right controls and these concepts that are discussed in this domain. As before we begin, is just that it has to be clear that no matter what you do or what model you choose in the cloud, the customer is always the the ultimate accountable party for data security. Um, that responsibility doesn't get shared or delegated to any other party. So what it also means that whether you're using IaaS, PaaS, SaaS, or public, private, hybrid, community cloud, as a customer of the cloud, you need to do whatever due diligence you have to do to make sure that your data will be secure um, before you choose to go for it. So there's a lot of things in this, as you can see on the slide, some concepts to begin with, and then data storage architectures. We talk about applying data security technologies. And then we talk about how you do data discovery, how you classify data, how do you label data, then how do you control data using information rights management or digital rights management, and then eventually how you retain, delete, and archive data, and what's the difference between each of these terms. And eventually, at the end, how do you ensure that the data, access to data or activities on the data are auditable, traceable, and you can put accountability on it. So yeah, I mean, it's essentially what you would be aware of anyway, regardless whether you're working in cloud, if you're in the field of data security or information security. But um, it's a good exercise to apply this in the cloud context, and that's where it makes a bit of a difference. So one of the key things when we start this domain is an introduction to the cloud data lifecycle. And this data lifecycle, again, as I said, it's not unique to cloud. It's the data lifecycle in general. Even outside of the cloud, it would typically follow the same steps. So there are three phases. It's create, store, use, share, archive, and destroy. And this domain talks about the controls that you would have to apply in each of these phases. What are the unique controls that you need to apply in each of these phases? So when you create data, it also means when you update data, that's that step where things like data classification comes into play. How do you rightly, based on the type of data and sensitivity of data, how do you classify data? What controls you use or mechanisms you use, classify data? When you store data, it again goes back to the concepts of encryption, because storage in cloud is always on a shared pool of resources. So as we said earlier, encryption is one of the main controls in the whole of cloud security that needs to be in place. So storage of data at rest, encryption is one thing that comes into play. When you use data or when you share data with others, um, concepts of data leak prevention or data loss prevention, how do you make sure the right people have access to the data, um, digital rights management, information rights management are some of the controls that gets discussed as part of that, those two phases. Archiving the data, when you archive data for long-term retention, you take the data and store it at an archive location, a separate location. Um, there are controls around who has access to the archive, because not everybody who had the access to that data in production should have access when it's in archive. So it's essentially um, who, from an access standpoint, from controls related to data format, like in terms of what format should the archive be uh, retained or should be restored in, so that it's usable. And lastly, encryption plays a key role, because again, in archive, you would encrypt data so that it's safe if it's stored in cloud. But since archives are stored for long term and encryption standards evolve over a period of time, how do you make sure that when it comes time to restore, you are able to decrypt and restore? Um, so concepts like key escrow, which is ensuring your keys, although it's a legacy encryption, you put some compensating controls by having, let's say, more secure network access, segmentation, um, auditing and accountability of access to the archives. But then also you store the original keys with a key escrow to make sure that when time comes, you are able to refetch the key and uh, decrypt the encrypted archives. So there's a lot there in the archive phase as well. And finally, the destruction, which is secure destruction, things like we talked about, which is crypto shredding or crypto erasure, as well as which is the primary control that you can deploy in a cloud setup. But then this phase extends in a non-cloud setup as well and talks about other ways of destruction and what standards you can follow, so on and so forth. But again, in cloud, the only way you can destroy data is using um, crypto erasure. So data dispersion is another concept that is discussed, and it's important to know about it. A lot of questions come on data dispersion. It's about it talks about it's the technique that is used to break data into smaller chunks, and it's very much, as I said, similar to the striping concept in RAID disks, right? So you are able to break data into smaller chunks and store them across different physical storage devices. That is data dispersion, and that talks about things like bit splitting and erasure coding. Very much similar to the concepts of RAID, where it's striping and parity bit calculation. Erasure coding is a concept where you can recreate the data if segments of that split or dispersed data are lost or missing. So these are some of the concepts. Actually, it goes into much more detail. It's not covered in CBK, but you might have to read these things separately on the internet, which are different types of bit splitting methods, the algorithms that are used to do these things. It's a bit too technical, but I'm just sharing that these are some things and some of the examples of things that you would not find when you do CBK only. It'll only come to you when you do questions and you realize that, okay, there's a question on the algorithms or different ways of doing bit splitting, and then you go and read it up. Um, the domain gets into different types of storage in context of the different cloud service models that you use. So if you're using an IaaS, what type of storage types you would be dealing with? Same with PaaS and same with SaaS. Um, I think this is straightforward. I won't go too much into it, but this is good to know that um, when you are at the IaaS level, you are at a much more infrastructure layer storage discussions. You're talking about volume storage, object storage, and things like that. The more you go higher up in the abstraction as SaaS, um, it becomes more about um, uh, managing storage as a service. So you would also have this concepts about content delivery network, making sure the access to the information that is stored in these SaaS platforms is well managed, and things like that. So threats to storage: unauthorized access, unauthorized provisioning, regulatory non-compliance. If your storage, I mean, these are some of the threats that are common to any type of storage that exists, even in the traditional environment. They just get amplified in a cloud setup, again, due to the fact that you don't have control on the shared pool, as well as the, let's say, the technologies that are being used for storage, right? Mm, For example, the regulatory non-compliance could be because there might be requirements to employ certain storage technologies which needs to adhere to certain standards, but how do you make sure that that is compliant is more about the conversation that happens as part of contracting or SLAs. Jurisdictional issues, because data dispersion, for example, where data is split and shared, distributed across multiple jurisdictions or regions, might lead to um, cross-border jurisdictional issues in an event of data leakage, right? Um, Denial of service amplifies, because if in a traditional environment, if your storage is not available, it only impacts you as a tenant or a single owner. But in a cloud setup, denial of service, not just for storage, for any such resource, would amplify across the entire tenant. So whether it's storage, network, compute power, in case of a denial of service, it basically then denies service at a larger scale to a larger stakeholder group. Data corruption or destruction, especially in context of archival. So if you're doing long-term storage or archiving, how do you ensure that the data is not corrupt? Are you doing integrity checks on a periodic basis? Are your keys for storage well managed, etc., comes into the discussion here. Theft of media loss will not be so much applicable to you as a customer, but more as on the cloud service provider end. So this is one of the risks you actually um, don't deal with on an operational basis, but is then a responsibility of the cloud service provider. And I think we talked about improper disposal, malware, ransomware. These are all threats that apply in general to storage um, across the board. Um, so data security technologies and strategies. When it comes to data security, the only biggest control, again, to reiterate myself, is encryption. Um, there's a discussion of Kirchhoff's principle, which is basically saying that the encryption mechanism that you've used, or rather, I would say, it stresses on the fact of the sanctity or the criticality of the encryption keys. It should the Even if the entire crypto system is made public, except the encryption key, your information should still be secure. So the only thing you need to protect in your encryption mechanism should be the key, and it should be so strong that if the entire mechanism of the crypto system is publicly known, but the key is not known, you're still safe and secure. It also talks about, so given that point about how critical the keys are, and keys are nothing but another type of data, and same data lifecycle concepts that we talked about earlier, which is create, store, update, create, store, use, share, archive, and delete, and the controls in each of those phases will apply the same way to the protection of keys. Like any other data, it has its own life cycle like any other data. um, FIPS 143, which is Federal Information Processing Systems for in crypto modules. So basically it talks about from a US federal government agencies, if you have to do business with them, or if they themselves are trying to employ crypto system, it should be tested as per the standards mentioned in this particular standard. Um, Given that many companies and many product vendors are already trying to reach that level of maturity, this is an important um, reference to know about, and it's best if it can be glanced through. It's something that is a very popular reference that keeps coming in CCSP, even in the later modules, like when we talk about uh, laws and regulations. At that point, it gets referred again. And encryption can be done at various layers. So you see the different layers, whether you are encrypting at the storage level, the volume level, the object level, application level, database level. Various levels or various layers in the cloud services can employ encryption. And depending on where you're doing encryption, you will have the flexibility to whether the keys or the encryption keys can be um, can be managed by the vendor, the cloud service provider, or by the customer. I mean, ideally, you should the customer should use their own keys or employ a third-party key management service. And all the principles should be that the keys should be stored separately from the data itself. But how much of flexibility you have to bring your own keys, and who has the responsibility to encrypt, whether the encryption happens at the cloud service provider end at the service level, or it happens from the cloud service customer standpoint. Those nuances are covered when we discuss about the encryption at each of these different layers. Uh, excuse me. So there are some of these concepts that you would come across in this domain when we talk about the different, other technology and strategies employed for data security. Some of these are very well known for a long time. Hashing, one-way encryption, which is used to ensure the integrity of information. Masking, where we basically, just hide portions of the data. Tokenization, which is mostly used today these days in the concept in the space of credit card transactions, how tokenization works and how it helps in mitigating the risk of compromising credit card or critical cardholder data. Data loss prevention is discussed, and it talks about the entire life cycle of DLP from the time you are able to um, from the data discovery to classification to labeling and then eventually monitoring, etc. So that's discussed. There are various ways of data obfuscation. Substitution means you substitute the data set, a critical, let's say, data set or a string or whatever, with some other number to substitute it. And all these are discussed in the concept of how uh, when you're testing or when you're using some solutions where you're dealing with sensitive data or regulated data, PII or PHI, what all ways you can protect it. So in that context, many of these things are discussed. Shuffling is basically you shuffle the position of the different data sets or the numbers within a data set. Value variance is where you shift by a static um, value. You shift everything, let's say +10 to everything or +5 to every digit within that string, sensitive string. Deletion nullification is just put everything with 0 or delete or nullify it completely. Encryption is a way to, obviously we have discussed enough about encryption to secure data, but there are also concepts of homomorphic or confidential computing, which basically means although you encrypt data at transit or in motion, but when it comes time to process the data, you still have to decrypt it. So while being processed, the data is unencrypted. So the technologies are coming in play where you don't even have to unencrypt the data when it's being processed. So it's still a nascent one, I would say, but That's something that's get touched upon. Pseudo anonymization is basically where you essentially process or obfuscate data with a specific goal of reversing it, um, reversing it at a later point. Um, and I think it is more like, you know, let's say if you are sharing your PII with a third party, you would remove the or a set of information which has PII with a third party, you'll remove the PII with an index, and when you retain that information back from the third party using the index, you can plug back the PII. So the risk that you're basically trying to mitigate is when you share a piece of information, you still retain the sensitive one, and you only share the the rest of it with the third party. And there is data de-identification and anonymization. Again, very PII related, very similar to pseudonymization, but in pseudonymization, you do it with an intent to reverse it. In this case, you just do one way. So you just remove or scrub out the PII information with no intention of recovering it again when you're sharing that information with some other party. So yeah, I mean, it's basically a quick walkthrough of different types of things that uh, can be employed depending on the context, whether you're using credit cards, you might use tokenization or masking. Whether if you're using testing, you might use substitution or um, masking again. If you're using if you're dealing with PII and third parties, you might use pseudonymization or de-identification, so on and so forth. So there's some other slides which talks more about all this, which I will skip for now. Um, yeah, these are some of the considerations for cloud DLP. So data tend to move and replicate. So how do you make sure your DLP solution is able to identify, discover, classify the data as it moves around? And also keep in mind that DLP affects performance. Some of the considerations one has to take when designing cloud DLP solutions. So see how we're doing on time. I think we are right on time. So let's do some more. So the rest of the sections here are essentially the whole, how do you discover data? How do you classify data? How do you label data? Then how do you protect it using solutions like DLP and DRM and IRM? So I think in that context, you'll see the next few slides drilling down on those specific concepts. So in data discovery, you first talk about what are the different types or sources of data. You have data lakes, you have data warehouse. They introduce these concepts so that you understand the meaning of these terms and how they are used. So data lake, data warehouse, which deals with either unstructured or structured data sets respectively. What is a data mart, which contains data that has been warehoused, but it is analyzed and made available only to a specific business unit. What is data mining, which is extracting patterns in data, online analytic processing, the use of data for machine learning and training AI models is also discussed. But the more interesting part is about the bottom one, which is unstructured data, right? So structured data, it's like an Excel sheet. It's easy to know where to go and which column to look for sensitive data to discover, which you can define rules around a particular um, predefined schema. In unstructured data, like a video file, an audio file, a picture, free text document, it's difficult to discover sensitive data there. So it talks about ways in which you would be able to do it, like pattern matching, which is essentially to try to look for certain pattern of sensitive data set, like credit card numbers are done in a certain pattern. So if you're following that pattern, probably it's a sensitive information to discover. Lexical analysis takes it a step ahead, so that if you're using in your discussion, if you're using payment data instead of credit card number, it will highlight that there is something which is relevant to be looked further into. Hashing is basically you use the hash value of some known sensitive data sets and you compare it against the hash value to see if it has something sensitive. So it talks about all these things so that you understand the different ways or mechanisms employed. It's the same thing which you can do on-prem. Doesn't matter whether you're talking about cloud or not. But cloud is always in the context, but they still talk about and touch upon these things because they are important regardless of cloud or not, right? Um, aspects driving data classification. Um, Again, this just talks about what um, what different types of attributes you would consider before you classify a data. So obviously there should be data classification policy, and that policy would say or would consider these different aspects of whether it's PII or sensitive data. Are there any legal aspects associated to that data type? Who owns the data? Is it our or we a third party custodian of another? And overall value and criticality of that data, so on and so forth. Um, and then based on the classification, you should be able to label it. So labeling is the next thing that is discussed. Uh, and there are nuances about labeling as well, which basically says um, it should, I think those are best practices. Like you should not have a label which says top secret, which just means that you're inviting trouble for based on that label. So some of the basics covered here in terms of data classification. And then eventually we come to what we call as digital rights management or information rights management. Information rights management is your, what is it called? Um Azure AIP, if you're using Azure AIP, very the same technology. Uh, it's called information rights management if you're using it within an organizational setup. In a consumer grade IRM, it's called digital rights management. So if you're using or renting a movie from Amazon, and it will come up with some controls that it has some time value to it, it'll only be usable to your account, so on and so forth. It comes in play for all these digital IPs. That's in that context is called digital rights management, but the concept is the same. Some of the key attributes are discussed when it comes to information rights management, which you might have experienced if you have used Azure AIP, that its persistence, like the enforcement must follow the data. So wherever that file or the data goes, the controls are persistent. It's always on. It's not, it goes with the data. It's a dynamic policy control, which means that you can update the restrictions even after the document has been shared, although there's a downtime to it that you cannot, um, um, you would have to have a network connection required for that policy to be enforced once it is updated. There's also just once. So there's a continuous audit trail, or rather, sorry, the next one is expiration, which is it's used in DRM, mostly the example that I gave. If you're renting an IP online, maybe a movie or music or an application, um, if it has a time-based control, you can actually implement using this technology. Um, Continuous audit trail, which means that it's the audit trail is maintained so that all activities are made or are traceable on what happened with that data, who accessed when and where, and it should be interoperable. And that's something that is a limitation sometimes, but the expectation that the true IRM should work across different system types, all different types of OS, different form factors, whether it's a mobile or a laptop or a server, uh, it should be interoperable. The same control should apply across. So again, I think the more interesting part would be to kind of do a bit of questions, because the rest of the topics, as you've seen in the flow here, are pretty standard data security concepts. But I think when you do the questions, that will help you understand more on how and what ISC squared CCSP is getting at when it comes to data security. So let's go to the knowledge check again. I hope you are able to log in just like last time, and I will activate the questions for us. Okay. So in which of these options does the encryption engine reside within the application accessing the database? I think it's a straightforward question though. Uh, so people have answered application level encryption. Let's look at it. I think I'll go to another view. Yep. So application level encryption is where the encryption engine reside within the application accessing the database. Let's move to one more question and then it will become more interesting. So you are the security team leader for an org that has IaaS environment hosted by a CSP. You want to implement SIM in order to acquire better data for security decisions. Which of the following is probably your most significant concern? Mhm. People are answering C. So which is the correct answer? Um, um, so C is the right answer because if you're implementing a SIM in an IaaS setup, although IaaS gives you the most control on the cloud service, but you still would need alignment with the cloud service provider because you will deploy certain, um, you will install certain tools or you will need some reporting capability. It is essential that you coordinate with the cloud service provider so that it works as expected. Um, right. Okay. Let's try one more question. Okay, so we talked about crypto shredding a lot. Um, which of the following is not a step in the crypto shredding process? Interesting. So actually the correct answer is, so remember it's saying which of the following is not a step in the crypto shredding, which should not a step in it. So the correct answer is save backup, because if you're saving backup of second resulting keys, then you're storing it somewhere, then you have to protect that. So there'll be no end to that cycle. In crypto shredding, you encrypt the data itself with a key first, and then you encrypt the original key with another key, and then you destroy both the keys. so that neither you as the owner of the data nor anybody else will ever be able um, to decrypt the data itself, right? So there is no point in saving the backup of the second resulting keys. Let's move on to the next. So data may need to be reclassified for the following reasons, except what? Yeah, I think it's a straightforward one. In general, I mean, in other words, I wanted to make the point that how and where the data needs to be reclassified, which could be time, its repurpose, or transfer of ownership. So what is sensitive today during this at this time may not be sensitive after a point in time. If it is repurposed, um, which means it has been, we've used some of the obfuscation principles we talked about, then it may not be that sensitive after it has been repurposed. And if the ownership has been transferred, it's no longer in your ownership, then reclassification gets triggered. Okay, next one. Proper dash needs to be assigned to each data classification or category. Right? Again, straightforward. Choose the right answer. Don't choose what would be relevant. There are many things which are, I mean, yeah, you can assign a dollar value, you can assign a metadata, you can control. I think all would be arguably right. But what is that one single answer here, which is the main point, which is security controls? At the end of the day, data classification directly suggests what controls should be applied to that data class. Policies would be overarching one policy. Um, Controls would vary based on the data classification. All right, so next would be, okay, I think this, I made a lot of, I stressed a lot on this already, so I think this should be straightforward. Yep, crypto shredding is the only way you could sanitize in the cloud, because you'll never have, or you may not have access to, or you may never have access to the physical destruction. Even if you get services where they do promise physical destruction, I don't think you can rely on it unless and until you do it yourself. Okay, let's move on to the next one. So what does non-repudiation mean? I think my questions were pretty straightforward. Let's see. Right, cool. That is what non-repudiation is. Um, I think this comes in the context when we talk more about investigations and e-forensics, e-discovery. Uh, a lot of those areas in the CCSP discussion, non-repudiation and how you manage um, chain of custody and everything is discussed. Okay, we'll move on to another question. So if the organization operates in a cloud environment, security operations procedures should include guidance for all of the following audit or logging processes, except what? Right? Yeah, so your procedures should be ideally tool agnostic, vendor agnostic. All the other points that are mentioned here make sense in terms of what is the security event or an incident, what qualifies for it, what is the process for adding new rules, and then eventually what is the process for fine tuning the rule set to reduce false positives. The brand or the vendor of the cloud provider's logging tool is not called out in a procedure. So if the organization operates in a cloud environment, security operation procedures should include specific contact information for all the following except what? Mhm. Okay, so this one is would be interesting. So the correct answer is actually the originator or publisher of the because there's nothing to do with who wrote it, right? Um, who wrote the procedure is not important. The procedure should include more about, um, in terms of notifying the stakeholders related to regulatory entities or law enforcement, cloud providers, security response office, if we need to engage with them, etc. So the originator or publisher of the governing policy is immaterial when it comes to um, the the execution of the procedures itself. All right, last question. Um, what should data archiving and retention policies include? Mm. So I think this is another one of the classic examples of ISC where you may have two very close answers. So the two responses you see up are both good candidates for it, but the right answer is option B, right? Um, because if you think about it, it's a policy that they're talking about. In a policy, you would not put names of personnel. Policy should be long, standing. It should not be dependent on names of personnel. Personnel may change. You won't be updating the policy every time personnel change, right? So the best answer is explicit statement of data formats and types of storage media, because as I said earlier, for regulatory reasons and for operational reasons, you would need to make it very clear of how the data needs to be stored, what storage media, what format, so that it is usable when time comes, um, not just for operational purposes, for even regulatory purposes, you may need it in a certain format or in a certain way um, when they are restored. All right, great. So I think we finished all that we had to do. I hope this was helpful. I hope some of the questions here, I kept the questions here a bit generic because we are not going through a lot of the content in the domains to get to really technical questions. But the idea was to um, give you a flair of what all it touches upon, what type of questions come, and then
Yeah.
some of the tricks that you need to, to use and think through in some of these questions where there could be more than one right answers. So thank you for your attention and time today. Sujit, are you there still? Do you have anything to add?
Yes, I just would like to thank you first and foremost. It's a marathon session, but you did very well. I mean, personally, I didn't feel like stepping out of this, though I had my camera switched off. I stayed glued to the screen, watching what you were presenting and also listening to what you were saying. It was very refreshing, and I'm sure everyone else, though they did not ask any questions, they would have found it useful. So I would like to also make an announcement that we will be back again next Saturday, same time, 1 p.m. So please register. There's a separate link for the next session, so you can register for it. And I would also ask you to spread the word around to your friends, those of them who would like to, pursue a career in cloud security. It will be a good opportunity to pursue the IC squared certification, because you would actually go across as a vendor neutral expert, right? And you would learn the best practices. You would be able to demonstrate to your prospective employers that you carry the knowledge and the experience to do your job well. So thank you, Anurag, for the time and for sharing your knowledge and experience. So I look forward to seeing you again next Saturday, same time.
Right. Yeah. Thank you all for your time as well. And we look forward to meeting you all. If you have any suggestions for the next session, please do share that as well with me on LinkedIn, if we'll be connected there, or to or to this. I don't know if you'll have the chat, but yeah, please do figure out to send those feedback to me.
Yeah,
I'll be available on LinkedIn.
yeah. Anurag is available on LinkedIn. I'm available on LinkedIn. If you're using any other social media platforms, you can always reach out. So we'd be happy to hear from you. Or if you do have any other topics of interest which you think would help you to, we can help you to learn from it. So please do let us know if there are any topics of interest. We'd be more than happy to host them for you. Thank you so much, and have a great evening and have a great weekend too. So see you next week.
Bye-bye, everyone.